Hi, everybody. Thank you. And thank you all for coming today. It's really an honor for us to have all of you here at Google Developer Day. So thank you very much for coming. So my name is Matt Marks, and I'm going to get started with my presentation, Building Scalable Geo Applications. I have a tendency to talk really fast sometimes. I'm going to try and talk slowly today just because I'm told that I should do that. But if I start talking too fast, please just wave your hand at me or something and let me know that I'm going too fast. Or if you have any really exciting questions, let me know. I don't mind being interrupted. Okay, so let me go ahead and get started. So many of you have probably built applications using something like the LAMP stack. That's Linux, Apache, MySQL, and Python or Perl or PHP, something like that. And these applications work really well and they're really easy to develop. The problem is that people then want to use them. So the big problem with building a successful web application is that too many people put too much of a load on your applications. And your servers have a hard time dealing with that. So the more people who are using it, the more time you spend doing things like load balancing, maintenance, sharding your databases, spending your time and energy building applications, building an infrastructure to support your application rather than building your application. So some estimates put this effort at about 15% of the cost of running somebody's application, running a website. So what I'd like to do is talk to you about some things that we offer to you, some ways in which we offer to you to deal with this problem, deal with the problem of scaling so that you don't have to deal with it yourself. And here are some of the other problems that we see in serving data. That are specific to geodata stores. With the geodata, you often want to have a multiple data format output. You want to be able to put it out as KML or JSON or sometimes even shapefiles or something like that. You often have specialized spatial queries. You need to be able to do, for instance, a bounding box query to say, give me everything that meets this, that is within this box, or within a certain radius of a location, 25 kilometers, or 1 degree. You also want it to be highly customizable. You want it to be you want to be able to do queries on your own custom properties. So you don't want to have a very limited data store. And you want to be able to rely on open geo standards like KML or GML or GRSS. So here are 3 products that we offer, 3 solutions to this problem. And you'll see I very nicely highlighted in blue what I think the long-term solution will be. But I'm going to talk to you about these 3 different options today: Google App Engine, the Google Maps Data API, and Google Base. And you can see here how I've highlighted some of these specialized problems. Multiple output formats, specialized spatial queries, customizable, serve large number of requests, and rely on open geo standards. And you'll see that none of these is a perfect match for any of these yet. But we do anticipate that the Maps Data API will soon meet all of these criteria. Okay, I'm going to start with the Google Base API, and I'm going to spend the least amount of time on it, largely because while it meets most of the criteria on that previous matrix, I think the other solutions offer better potential long-term. And I'll talk to you a bit more about that as I go along. So Google Base is essentially a giant XML data store. You put in your own data using either an upload process through our website that we provide to you, or using our Google Data API for Google Base. It has a lot of interesting properties. We actually use Base as a backend for many of our services, including Google Product Search, which formerly was known as Frugal. I don't know if it was known that.
So I can comment. 事实上，我们做一个地图上有一个Google 有个产品叫生活，它背后就是可以收火车票、收房产或者收等等，其实也是 Google Base 的 backend. So I just say the channel product 生活社区 is kind of Google Base backend.
Okay. So one of the reasons people use Google Base is it makes things very easily discoverable to Google.com. If you put something in Base, we know about it. It gets indexed unless you tell us not to. It has built-in bounding box and radius searches, and these are the specialized queries that probably 75% of all people building websites needing a spatial query, those are the things that they need the most. It's got a Google Data API. So Google Data is one of our standard ways of querying data from Google services. It's built on the Atom publishing protocol, and I'll show you a little bit what that actually looks like. The Maps Data API is also built on a Google Data API. You can also access it just as a feed of XML. You can get the feeds directly, or you can use one of our client libraries, one of our many client libraries in different languages. It supports a set of standard and also customizable attributes, so you can do queries based on your own attributes or some of the standard ones that we provide. You can get the output as XML or JSON. One of the disadvantages of Google Base, and this is one of the things one of the reasons I discourage its use, is the upload time can actually be a fairly long upload time. So this is a quick look at how you would put an item into Google Base. This is a personal ad. So personal ad is you place a classified ad for you want somebody to meet, to fall in love with. So here's a simple. You see the HTTP request at the top. It's a post to this basic URL. You give it the content type. There's a whole piece on authorization, and you give it a Google key, and then you post this XML here. And you'll see this is an entry, which is in the Atom namespace. So it's a standard Atom entry, and then you've got some other standard Atom items in there, like the title, and then these in the Google namespace are with the G prefix. These are things particular to a personal ad. And this is how you would do a simple query on the feed. Here you'll see at the top is the full URL. It's all one long URL. If I were to click on that, it would show me an XML entry for every one of these things that we're returning in the query. I broke it down here into 3 spots. The first line is just the base URL. So you see there, google.com base feed snippets. This is your base query, and so it's got a special query language built into it, and that just says, give me everything of type personal ads. And then this here is a special location query, which just says, give me everything within 5 miles of this latitude and longitude. And at the end, you'll see it has a parameter content equals geocodes. So that just tells it, give me this feed and give it to me with a GRSS built into it. I did a demo of this. I did this for Valentine's Day. I don't know if Valentine's Day is celebrated here. It is? Okay, good. So I did this for Valentine's Day. Here, querying the personal ads, and you'll see that it actually adjusted the space. This is Google Earth, by the way. This is the Google Earth plugin. I'll be talking about that later today. You'll see each of the little hearts there represents one entry returned in the radius search. And you'll see there it gives a table of data about the individual. This is a quick application I built on App Engine. I just used some simple Python parsing of the XML output. So let me tell you just to sum up Google Base, because we're going to move on now to App Engine. The big problem, two big problems with Base. One is that the upload times take a long time, and the second is that we're not putting a tremendous amount into future development of Base. This isn't a guarantee. We might do this in the future, but we're really trying to move specialized spatial queries into the Google Maps data API. So we'll talk more about that in a bit, but for now, Base provides a nice, decent way to serve your data, and there are probably people who are now putting their data both into the Maps data API and into Base, but if you're trying to get data out, I think some of the other options will be better. Okay, so let me move on. So the next thing I'm going to talk about is Google App Engine. And how many of you are familiar with Google App Engine? Do you know what it is?
这位多少人听说过了？听说过还是有一些。
Okay. So for those of you who aren't familiar with it, Google App Engine is it's a service that we provide. Basically, it allows you to develop your applications and run them on our servers. So this is something very different from the Maps data API and the Base data API, which both are a place for storing data, and your application runs somewhere else. Google App Engine, the entire application can run on our server. And these are all the things that we think are important about it. It's high performance, high availability. The development is very easy. You can run either Python or Java environments on Google App Engine. It's free to get started, and this is one of the interesting things. It's built on Google's infrastructure. You're basically working how we work. So you're developing how we develop, and so you don't have to do things in App Engine like worry about the number of machines that you're using or do any load balancing or sharding your database. All that stuff we take care of. It's all in the back end of Google App Engine. So, and I believe we have some App Engine talks later, so if you want to know more specifically about that, you can. I'm going to walk through some of the that's my next slide. Some of the advantages and disadvantages of it. So as I talked about, it's built for scaling. So you write your application once, and then you can scale up to however many users you need, and just pay us for the amount that you use. So there's a good example. There's an application called BuddyPoke, which is an open social application. Some of you probably have it in one of your social networking sites. They scaled up from a few users to 4 million users in the space of about a month, and they never touched their code. They never had to do anything to adjust that. And they're now up, I think, last I heard was around 7 million, but that was several months ago. So it's built to scale very easily, as I said, and all you pay for is what you use. So as opposed to, so I'm not sure how web hosting works here in China, but in the United States, typically you say, okay, I'm going to purchase so much web hosting, so many servers, and I will pay so much a month. So Google App Engine, you're paying for the amount of bandwidth that your application is using, the number of times people hit it, and the amount of CPU usage that you're using on the back end of our applications. And you only pay when your application is actually accessed. It's replicated in data centers around the world, which means that you don't have to worry about backing up your data. You can use any standard Python or Java libraries, although not any C++ libraries, which many of the high-end open source libraries are built in C++, unfortunately. We built in easy authentication, so if somebody has a Gmail account, you can authenticate using that Gmail account. It's trivial to do that. It's also highly customizable. You're creating your own applications. So you're running your own applications on our servers, and it's just as if it were any other application, just using our specific built-in APIs. So there are some disadvantages, particularly for spatial applications. There's very limited spatial support built into queries, essentially non-existent. There's a limitation in inequality queries, which I'm going to talk about a little bit later. Actually, let me talk about it now. So typically when you're doing a query on a relational database, you might say, give me everything that has a latitude between X and Y, a longitude between W and Z, and say a property value of, say it's a real estate, so its property value is over $10,000 and less than $100,000. So that's three different properties that you've done an inequality query on. You've done an inequality, greater than or less than on latitude, longitude, and property values. Now in App Engine, you only allowed it on one. So you could do latitude between X and Y, but then you couldn't then also do something on longitude, which excludes the use of inequality queries. So that's a pretty major limitation. I'm going to talk about some ways, two strategies for getting around that. And the other disadvantage it has for all applications is it's a very different way of programming. A lot of people take a lot to get used to it. I think it's a cooler way of doing it. It's a more exciting way. It's the way we develop, but it's very different from using your traditional relational databases. Okay, so I'm going to walk you through very simple App Engine, some very simple App Engine code. Here is defining a class. This is using Python, although I see that my slides change my indentation. So if you know Python, just you can probably mentally put in the indentation, and I'll fix that in the slides later. But this is creating a very simple class called myLocation. And you'll see here it has a name and location property. The location is a geopoint property, which is one of the default ones. And when you see geopoint, you get excited and you think, well, that means that there's a built-in spatial support. But you don't really get very much for that. And this is how you do a very simple query. This is your standard query in Google App Engine. You get a query object which equals myLocation.gql, that's the Google query language, which is, we always say it's similar to SQL, but it's really, if you're familiar with SQL, it's really only the select where statement. So you see there GQL where name equals some value, foo in this case. So that's a very simple application. Doesn't really do very much. But let's talk about some of the strategies for getting around this limitation on the number of inequalities in a query. One is geohashing. So geohashing is a way of taking the latitude and longitude, mashing them together and creating one string value. And that string value allows you to then do the query using the one inequality query. It's based on an open source library. You can go to geohashing.org and download the Python code for it, and then upload it to your application. A number of people use this. This is the first pass that people used at creating geospatial applications. It allows you basically to do a simple radius search. If you specify that the precision of your query, so say you have this string. The string is your geohash. You specify the precision at which you want it, and that defines the size of the radius. The more precision you have at matching your string to the strings that you're querying on, the more precision that you have, the smaller your radius, and the less precision, the bigger. And it has the advantage of it only uses your one inequality on one property. So the second strategy is a geomodel strategy. This was developed by Roman Nork at Google. Basically, what you do is you divide the world into a 4x4 grid, and I'm sorry, a 16x16 grid. That's right, 4x4 grid. It's like a quad tree, which divides the world into 4 spots, but I don't know how to say a 16 tree. So divides it into these cells. And then each of those cells is divided into another 16 cells. And then each of those, depending on the zoom level precision that you want. And essentially what you're doing is you're taking every entity that you create, everything that you put into your data store, and you assign it a value at every zoom level. And what you will then do when you do a query is you will say, okay, I want all these cells. Now give me everything that matches one of these cells. And then, so you're finding all the entities in each cell, then you order them, and then you display them. So it's a rather complex way of doing the querying. It has these advantages. It doesn't use an inequality query because you're actually just doing equality queries. You're saying, give me every cell that matches a particular value. And it's the library, it's an open source library that we released. It's customizable for different zoom levels, resolutions, and different grid types. So you could use it with different projection systems or different coordinate systems if you wanted to do that as well. The disadvantages, however, are that it is complex. So it's pretty hard to work through the code and get it to work with your code. And it doesn't scale very well for use with other geometry types. So it works very well for points, but it doesn't work very well for polygons or lines. You would have to go through and calculate every cell that the line or polygon touched. And that's just computationally much more complex, especially since generally when you're given a line or a polygon, you're given a set of points. So what you would have to do is calculate all the interim points in between the points, and then figure out which ones lie there. So I'm going to show you just bits of the code. And this basically, I guess I don't want to walk through each bit of it, but this basically just calculates a particular cell that an entity belongs to. Okay, so I have, so it's not in here. So I have here a demonstration built on GeoModel. This is a geomodel.demo.appspot.com. This is what Roman did here was he downloaded, I think, 100,000 place locations in the United States from geonames.org, and then place them into his data store. So basically what I want to do here is demonstrate how quickly you can get some results even based on that number of entities in the data store. So here, and I also want to show that you can do multiple inequality queries here. Sorry. Okay, so what I'm doing here is I'm putting in the search summary of San Francisco and giving a minimum population of 150,000. And it's going to find all the locations around San Francisco that have a minimum population of 150,000. And you'll see there it's displaying it on a Google map. And so that's a fairly quick response time. If you are interested more in this, if you go to Google Code Hosting and look up GeoModel, and I'll put a link in the slides to this as well, then that'll take you to the open source code, and you can go through that. So I want to take a moment here to stop. I've talked about a fair amount of things. I've been talking now for about 30 minutes. I just want to see if there's any questions before I move on to the Google Maps Data API. No questions? Okay. All right, so last year at Google I/O, we talked about the Google Maps Data API. We announced that we were going to be releasing it, and then we spent the better part of the year actually getting it right. So the Google Maps Data API is it's the new backend API for Google My Maps. So if you go to maps.google.com and click on My Maps, you can create your own maps using our editor there. This accesses the backend data there, so you can programmatically put your data into the Google Maps Data API and query it out. So it is a Google.
I the comments here. Yeah, actually we have demos. 我介绍了去我们展示的一些，比如像雪灾啊、像地震的一些物资啊，其实都是用我的地图的技术做的。当时它现在只提供了一些用户可以自己编辑，不需要编程序的界面。那么我们今天介绍的会说怎么用程序来控制这些内容，怎么用程序来发布你的内容，同时可以放在公共的地图上。Okay.
So Google Maps Data API is, like the Google Base API, it is a Google Data API. It's not a place where you can run your own applications. You can simply have your applications access data that's stored in it using the Atom Publishing Protocol. So at this point, it offers a storage of geospatial data. You can store points, lines, and polygons. You can create and edit My Maps. So you can create each map, or you can create and edit the particular maps. You can choose to have that data indexed by Google Maps. So when somebody does a query on Google Maps, things will show up. So this would be a great way for you to put data about your businesses or your store locations or something in there that you want people to be able to find using a geo search. You can put in your own user-defined attributes, so you will be able to do queries based on whatever attributes that you put into it. It allows for doing batch updating as well as incremental uploading and changing and downloading of changes. And it has a variety of client libraries in languages like JavaScript, Java, Objective-C, I believe, and PHP. And I've actually got a slide on that later. So this is the basic structure of the Maps Data API. You saw briefly some XML earlier for Google Base. This is essentially how, a very similar structure, but we have the diagram here. So each map is a feed, and the feed contains a number of entries. I'm sorry, there's a maps feed and there's a features feed. The feature, each map contains a feature feed. Each feature feed contains a number of entries which have the standard Atom publishing protocol attributes, and as well contain a KML placemark. So let me just take a moment to mention KML. KML is the Keyhole Markup Language. It's a standard that is released by the Open Geospatial Consortium, so it's an open standard. But it's also, it was originally designed for Google Earth. We gave it up to the OGC, and now a number of different applications both produce it and consume it for themselves. So basically what you're doing is you're using Atom Pub as a carrier for KML. And then the KML stores the actual data about the point into the Maps Data API. So there's built-in authentication, so you need auth sub, OAuth. Give for a client login, the service name is always local. There's much more details about this in the documentation on how to do authentication. And this is the base URL there, maps.google.com/maps feeds maps default full. We support these 4 basic verbs: get, post, put, and delete. Get, you can get a list of your My Maps. Post, you can create a new map. Sorry, this is for the Maps feed. So get lists your My Maps. Post adds a new map. Edit edits the metadata about the map. And delete removes the map. So you can set title, summary, and set whether something is public or unlisted. And then the feature feed, get lists the contents of the map, post adds a new feature to the map, put edits a particular feature on the map, so you edit an entry, and delete removes that feature. So you can do a variety of things like set the title, change the geometry or add a geometry, embed style in order to control your appearance, create a new HTML description, and then associate custom properties with the feature so that you can query on them later. And this is just a post that adds a feature to a map. So you see here at the top you have Atom is your root. An Atom entry, sorry, is the root for this entry. Defines the various namespaces, and then you have a title and content, and then you have a place mark in here. And this is in the default KML namespace, which you'll see the default namespace is KML. And it actually has some Atom within the KML, because KML does support a couple of Atom tags as well. So then you see here it's a description, you have your style and a geometry, which has a point. So this is just a sample that shows how whether or not your content is indexed. So if you don't want the content to be searchable on maps.google.com, this shows you how to turn that on or off. Here you've got these app control. This gives a the app namespace. And basically, you just app draft. If draft is yes, then it's not indexed. If it's no, it's not. It is. You also have quite a bit of control over attribution. Individual maps can be attributed, the individual features can be attributed to the person who uploaded them, and then within the KML itself, you can give attribution to the KML content there in case you're uploading KML from somewhere else. So by default, content is attributed to the account that it was created under, and then those links will display in the search results on Google Maps. If you want some different behavior, you can use the KML attribution. So there's not any need to actually write out all that XML, although I'm an XML head, so I actually like to write my own client libraries for this sort of thing, for the specific to the application. But we have some great client libraries built in Java, JavaScript, and Objective-C, and also we created PHP library. And then many people use libKML for processing the KML itself. And this is just a Java example. You can see how here it actually allows you to set your user credentials and then allows you to get a feed and then add a custom property and annotation to each of the features in the feed. So here's our roadmap, and here's why we think that this is the Google service for you if you're building spatial applications. These are the things that we're going to add to it. We're going to add search via the API. That'll allow you to do search by keyword, by attribute, or by location, so you get bounding box and radius searches. We're going to allow for richer content, not just KML, but we're going to figure out ways for you to upload associated content with that. So that might be images that would display in the description balloon, videos, something like that. We're looking at better integration with the Maps API. We are looking to add more structure to the feeds and different kinds of feeds as well. So I'd like to, I think I've got about 20 minutes. I'm going to do a demo here. And this is one of my favorite demos, I think, ever. This is a demo called MyEarth. This is one that we developed internally. And to use it, I'm going to log into MyEarth. I'm going to do that using my Gmail account, and I'm granted access. I'm already logged into my Gmail account, so it just has to ask. And then you'll see here it's going to load the Google Earth plugin, and you'll see up there it has a list of maps. So these are maps associated with my own private account, and I'm going to show you. Let me show you Mano's European tour. This is for Google Developer Day last year, I went to a number of different locations in Europe, and so this is showing you where I was there. So you'll see here it pulled the data out of the My Maps. I'm not sure why I'm getting a little error message. I think that's the demo gods are frowning on me. And then I can get information on each one of these locations that I saved onto my map here. And look at that, I stayed in the Crown Plaza, just like I'm staying here. Okay, so you see here, there's a whole bunch of different locations that I stayed in. And that's really interesting. So that's basically pulling in the data from the data API. But you'll see there's also an edit button. If I click on edit, it allows me to edit the map. And you'll see here he did something really clever. If you're familiar with Google Maps or My Maps on maps.google.com, you'll see these are the same editing buttons that we use there. He recreated them because they're an internal service. He just used the same icons for it. But it allows you to click on here. I'm going to create a new place mark, drop it there, click on this here. He recreated the whole Google My Maps experience, but he did it as an open source project that anybody can do themselves. I'm going to just put this down for a second. Here is going to allow, I'm going to select the different icons that will be used. And since I selected a martini glass, I'm just going to call it a bar here. And select close. So I could also create a line here, or what is in maps referred to as a polyline. And a polygon. My line disappeared. Still getting used to the controls there. And then I can edit that line. And so I've got a nice polygon and a new place. These polygons and this place don't actually mean anything. They're just what I did. Click done, and then save. Or sorry, I should have clicked save and then done. And now if I go to maps.google.com, and I'm already signed in using my Gmail account, I click on My Maps, and I go to Manage European Tour. The demagogues are frowning on me. I need to click save again, sorry. I'm having some response time problems. Anyway, so what should happen is this should actually show up on Google My Maps. And then there's a number of different applications out there that are already using this and quite successfully. So let's see if I reload this one, if it'll work this time. Go on Maps, My Maps, and Manage European Tour. Yes, actually, it is there. So you see there's a polygon, and it doesn't seem to, I seem to have had a problem with with looking for the bar here. I don't see the bar. Anyway, so basically that's how it works. All right, so I have another demo. If we have time, I can show you how somebody else is using it. If you want more information, we have plenty of documentation there, and we have a developer forum for the Maps Data API as well. And I believe that is it. So now I'd like to take questions.
对，到一个提问，用中文或者英文都行。
Can I share my maps with my friend?
Yes, you can. At this point, so Google My Maps allows you to share maps with your friends. At this point, the Maps Data API doesn't allow you to edit them programmatically, but that's something that we will include in the future. So any maps that you share with a friend, you will be able to edit.
But he
them.
can't edit the map.
You can edit the map in our editor, but at the moment you can't edit it using the Data API.
I have one question on Google Maps on mobile.
Yes.
For example, I search some address and I found some wrong information. Do you think as a consumer I can edit the information?
Yes, you can. I'm not sure if you can do that in Maps for Mobile, but you can do it in Google Maps. You can edit the different locations.
Thank you.
我想补充一下，如果大家搜地图的时候感觉有错误的时候，有一个编辑的窗口，你点编辑，然后你把你的正确的信息提交上去，我们会收集到一些反馈。
在手机上。
Thanks, Mr. Romano. Yeah, you just mentioned if we have information and we could edit the geometry in the web, and also we could from another website to find the geometry. So I concern the security. If I have a geometry maybe very important, and I do in my maps, and also maybe other one could also look at this information. So what do you think about that?
I'm sorry, I didn't follow. You say you're concerned about security of your maps that you create using Google My Maps.
Yeah.
So that's fine. If you want, you can create the map and make it unlisted. So therefore, nobody else can search on that map. However, if you log into another site that uses the Maps Data API and you authenticate to Google, it will be able to get your unlisted maps as well.
Okay, thank you.
Okay, thank you. My question is about the spatial query.
Yes.
That means when I query from the Google, that is a local search, and I found that the API just provide 8 records. So when my answer or my result is more than 8 records, how do I handle this question? How do I to show the next page on my application?
So using the Ajax local search API? Pamela's raising her hand. I haven't used the local search much. There's a Google bar on Google Maps that gives you a certain number of results as well, and that does allow you to page through. However, Pamela, can you comment on the Ajax getting more results? I think you can only do the 8, right?
I think we changed it in the last few months so that you can paginate up to 32 results in the API. You can certainly get them all using the Google bar.
Right. So if you use the Google bar, which on Google Maps, if you just put in the Google bar, you can page through all the results. In the Ajax local search API, you can paginate up to 32.
对，我下一个讲座叫高级应用，会介绍这个应用，对，包括可以看更多的结果。
我想问一下，今天早上你登录了高考那个 Google Map， 你是不是打算把它做 open source 的？你觉得是不是打算把它做 open source， 然后我们别人可以在这个基础上进行 contribution， 然后呢继续开发呢？
对，其实它就是一个网页吧，就是利用 Maps API 做的一些网页，所以你完全可以看到它源代码，你可以看看它怎么实现的，对。数据源是我们和一个第三方的一个教育的机构所获得的一些数据，所以如果你要更多的数据，你可能需要与他们合作的。这没有贴图支持的。
I want to ask whether it supports KML image overlaying or timeline or some other advanced KML features.
So not currently, but we're planning on adding that.
So where should I store the image data? Can I upload it to the Google server or any server I can access from the URL?
Yeah, so at the moment you would need to upload the actual images to a separate server. So one option would be if there's not a lot of them, you could upload them, say, to Picasa. Other people use Amazon S3 as a storage or just their own servers as well. And then in the KML, you would reference the external location. However, in the Maps Data API, we do hope to be able to support those in the future. So you would be able to upload, say, a KMZ that had your images in it, and then we would support that.
Okay, thank you very much.
Sure. Oh, App Engine is another option that some people use for tiling. They store the image as a blob in the data store.
Thank you. My question is about the logo. What does it mean? I think it is interesting.
Our logo?
Yeah.
These on here? This is the standard developer day logos. You'll see the round one with the circle in it. Is that the one that you're pointing to? That's the Google Chrome logo. Interestingly, there are no geo logos anywhere on here. But you'll see the little, looks like an airplane engine. That's App Engine. That's Glitz. That's Android over there. Gears. Probably Open Social. I'm not sure of the Open Social. Okay.
学英语的。
还有问题吗？
Thank you. One more question on Google Maps. So you mentioned the consumer can edit the information on Google Maps. Well, how can you make sure the information is wrong or correct? The accuracy of the information in Google Maps.
I see. So for local business results that are edited on Google Maps, we moderate them. So when somebody edits them, we go through and check the edit to make sure it's accurate.
等一下，给后面的一些机会。谢谢。How many records could I put into the database, or is there any other kind of limit for developers, such as how many times my data could be accessed per day? Thank you.
So there's no limits on the access. There is a limit there's a quota on the amount that you can put into it. I'm not sure what the exact quota is. It should be in the documentation. We're hoping to increase that very dramatically in the future. What we're doing right now is we're releasing this. It's obviously an early stage. It's in labs, and we want to test how people use it. And we're also looking at making sure that people don't spam our Maps Data API. So there's a lot of concerns that we have to make sure that this works well. And once we feel that we've addressed that, then we'll open up that quota and make it much larger.
行，我们最后提两个问题吧。好 ，just last two questions.
Okay.
你好，我想问一下，在这个地图上面，就是刚才我看到有几个点，然后把几个点连在一起了，可不可以就是给出这两个点之间的就是直线距离，或者是航空距离，或者是那个公路距离，可以有这些数据是吧？好，谢谢。
So middle question.
My question is, can I download field my data locally so I can use it offline?
Yes, so the Maps Data API allows you to get a list of all your maps, and then you can download all the features of each map individually. And then it's XML, so you can just do whatever you want with that data. You could create your own server of it. And there's actually, I forget what it's called, there's an open source project on Google Code Hosting that allows you to build your own Google Data server using MySQL backend. I'm blanking on what it's actually called right now, but if you do a search on Google Code Hosting, you should be able to find that. You have to customize it yourself, particularly once we add in spatial queries. But we believe that, we built this all on open standards, AtomPub and KML, JSON, so we're happy if people recreate this somewhere else, maybe set up a local server, set up their own Maps data servers themselves. So, yeah.
So-
All right, thank you very much. Hope you enjoy the rest of the conference.
Thank you.
Thank you.
如果大家还有问题的话，可以很交流，对。如果大
Yeah, you feel free to ask me questions. I believe Simon has a quick announcement as well.
感谢大家参加我们今天这个 session， 然后
我再介绍一下，如果大家对地图有兴趣的话，会有一些非常精彩的讲座，包括怎么提高地图的性能，非常多的技巧。然后，如果大家对移动非常感兴趣的话，可以听移动的一个地图 API 的一个讲座，我们会介绍一个。V3我们现在用的是第2版的地图 API， 然后我随后也有一些就是 API 去年1年发布的一些非常新的一些技巧和一些真人的一些展示。然后如果想大家对这个 Google Earth API 有兴趣的话呢，最后可能有一些 Google Earth API。谢谢。